you need to have on your at your data center, at your routing junctions, everywhere. You need to modify the protocol so that everywhere, so every protocol layer, you can reduce the processing overhead. That means, or the processing time. That means your overall latency, end-to-end latency, application latency. So every protocol, every protocol you have to think of optimizing. And you will see people talking about Quick these days. Google is coming up with Quick. So Quick is nothing but one of the many efforts that are going in reducing the latency. Of course, Quick has several other implications. So how are you going to reduce the latency at the transport layer? Quick. Right. So these are all, kind of spectrum of technologies that I will talk about. So 4G, 3G, they are all about just data rate, packet transmission, all voice over IP and all these things. But now the spectrum is changing. So this is just a summary of what are the problems of IP. Now this is one snap that I took in Valencia, I think in March or April. So they had this 5G global forum where many countries were involved: China, Brazil, Korea, Japan, USA. So they are basically demonstrating the power of 5G, what they have done, and all this. And this is actually the first ever real life holographic chat that I will see. Now I put a question. Can you tell me which person is real in this? So one person is not real. One person is basically a holographic image of a distant who is somewhere sitting somewhere 5 kilometers away. So can you tell me whether the green one or the black one? Green one is real one, right? Yeah, it's the holographic. So a few days back I showed this to another college and everybody said that it was black. So you are more intelligent. Yes. So these were basically done by Orange and ZT in Valencia. So they had, so the guy in green, he is the orange guy sitting in orange office, which was 5 kilometers away from the conference. And what we were seeing is the real life, what you have seen in Star Wars. So that is going to be real. So, but of course, when I drill a bit deeper and spoke to the engineers, there is still scalability issues because this is still one hub communication. So between so if you so I said that can you promise that this will work? We have 5G in India, so between Beijing and Delhi, you will have this kind of, so your political leaders will not need to waste so much money and have sessions everywhere. So we will have just holographic images roaming around here in Mahabalipuram and having a good conversation. That would have saved a lot of money at both ends. Anyway, so they said no, it is still not scalable, and that's understandable because one of communication is when you have raw 5G communicating. So there, the last mile is everything in the network. So the base station is there, and you have the 5G receiver is at the conference end. So this is an example of the business to business communication that is going to revolutionize. So this much has been done. So that means things will progress now in coming 5 years. Okay. And unfortunately, we are still lacking in India. Anyway. So IoT, 5G, data journey now, all put into cloud. You're processing that data. You have AI in cloud. You're getting exciting new services, and also building a lot of privacy. That's data. Now, when we talk about IoT, And this is for aspiring engineers who want to talk over IT. So, what are the aspirations you should have when designing IT protocol? As I said, that this is going to be this is very different than human to human interaction. So, this is machine to human or machine to machine interaction, right? And these machines are all tiny, mostly are sensors, and they are battery powered devices. So, they are energy constraints, they are bandwidth constraints, because they may not always get the best quality of radio. Imagine that you have put some sensors under the bridge in a distant place, and you want to track the health of the bridge. And so under the platform of the bridge, you don't know how the radio is going to behave because there is water and there is the concrete obstacles and all these things. So the radio is also not going to behave as expected because radio is open and prone to a lot of interference and external hazards. So how to be resource efficient? When you design a protocol, you have to remember that each protocol that does certain number crunching of your, so you put your user information that does certain number crunching, and from the and that number crunching is going on layer by layer, till you go down to the physical layer, and from the physical layer you push the data out to the media. Okay, so the more you do number crunching over there, okay, the more you waste your energy, and the more you have overhead in the data. So if you have if you have gone through Shannon's channel theory, so there are two things. One is data and one is information. So I pick up the phone, I dial the number, and the other party picks up the phone and says hello, and I just say that I just wanted to say happy birthday to you. And so your information is only there. Happy birthday. But if you look at the full set, so there are a lot of processes that you need to do only to carry that. So you have to think in this way. How you can put the information in an efficient way so that you have to do less number crunching. Okay. So that the amount of data that you want to use for certain amount of information is proportional to the bandwidth that you are going to use and also proportional to the energy that you are going to use. And security, of course, there is security overhead. So if you put the security, how the security and how to ensure that not everybody attacks the infrastructure at the same time, not every sensor trying to send at the same time, so that will cause a melting down of the system. The traffic pattern is going to change. But the biggest question, so many sensors, how do I access them? And there has to be standardized means. Otherwise, one vendor will not talk to another vendor. One sensor will not talk to another sensor. And one of the core value of the internet was the end-to-end principle that anybody should be addressable by an address, and it should be able to talk to anyone in the internet ecosystem by another with having another address. So how to do that? And now combining this with with 4G, launch of 4G, at least one or two subscribers, they have really should the IPv6 adoption adoption rate. And we are now figuring, we are nowhere in the world before 2016, and we are now figuring a very prominent position worldwide after 2016, after the IPv6 launch, because the new dongles, 4G dongles, 4G phones, and all these things, they are allocating IPv6 access. But still, it is not an all IPv6 environment, because many services are still in that. So it is still going through different patchy kind of network migration. You have certain junction points which do this backward mapping from IPv6 to IPv4. So network performance is definitely not going to be very good. But now, technically, we are not technical people. How do we achieve with IPv6 more address? Because 1.2 bit address space is the problem. And there are several other aspects also which you get more efficiently. And how do you reduce the latency? See, in IPv4, if you have read your network, you get something called segmentation and DSM. So there is another term called MTU, or maximum transmission. Okay. So MTU is how much data you can come inside a single packet, right? So this MTU, so maybe your MTU, you are sending from an internet, and you have the MTU of 1500 bits. So and your application wants as much as it can to these packets, but there is one router which has higher end 12. So what it will do? It will fragment all packets. Whatever packet it receives, it fragments. More fragmentation means more states are being created for a single packet, because actually it becomes like a tree structure. Okay, you're creating more segments and more paths. So more segmentation and reassembly is happening. Because without reassembling, IP layer is not going to send the packet to the higher layer. So IPv6 with ICMP-V6, it has come up with something called path MTU discovery. So it is giving more control to the application layer. So the application, before you send the packet, you can actually trace the path. That what should be my MTU all across the path, so that application can packetize the data such a way there is no fragmentation. There is no unnecessary uncontrolled states being created. And that actually has a effect on the overall routing latency, and in turn, overall response time that you get from the network. The header bits have been the parsing has been made less complex. Earlier in IPv4 you had checksum and all these things. So every IP packet used to go through this checksum. But IPv6 has removed that, because the lower layers are anyway doing a lot of sanity check. Now this is what happens when you create different layers in silo without talking to the developers of the other layers. Because the lower layer protocols, they come from 3GPP, they come from IPv4. Higher layer protocols, they come from IPv4. Both developers have to talk to each other, so that, because after all, it is a single user that is going to the whole stack. So, and the number of the time you leave all these numbers, all these fields, they have been parsed out. And I told you the packet structure. So the less number of header means your parsing complexity of each field is getting reduced. So that is also reducing your complexity. And also for they have in IPv4 the only routing algorithm that they had is open source. But now in IPv6, the new algorithm that is called RTL, routing protocol for low power and lossy networks. So the routing protocol has been designed in a power efficient way, so that you, in tiny sensors, if you have a wireless net, so the tiny sensor can do routing efficient. And the other thing is, here at the routing layer itself, you can say that this packet cannot tolerate any delay. So there is a packet classification. So in IPv4, it was more like so you have to do special bits so that you want to push one packet, so the ISP has to be taken into confidence and all this. But if the application itself can say that this has a higher QoS requirement or quality of service requirement, I want this packet to be delivered. For example, for air and ethical for augmented reality and like telepresence, so where you want or machine control, you want the actuation to happen right now. So whenever you are giving the command as if you are there, so your packet cannot be stored in a queue. If it arrives in the queue, you prioritize that element in the queue and you have to release that. So these things are all included in IPv6. And these were there, but we are not discussing it. We are not taking it very seriously. But now is the time we have to take it very seriously because this is the standardized to gather the needs for the future. So IPv6, we can say that it came much early than when the requirement was there. Just like Boolean algebra. So Boolean algebra came much early than when we actually found the necessity for that, right? And so I have been talking that IPv6 will reduce latency, but does it really reduce latency? Akamai and some universities they jointly published a paper in 2016, and Akamai is they are the content delivery network provider, and they made a study in US for different operators with different kind of IPv6 configuration. So IPv6, IPv4, NATed IPv4, and all this. And there they found out a very clear conclusion that yes, indeed, when your network is all IPv6, it does reduce the latency and enhances the quality of service in terms of the response that you get, the page loading time, and all this. Okay? So that is kind of an experimental proof. So if you want, you can go to that paper. And this is the Internet Advisory Board, IAB. They published a statement in 2016, and the concept is, or the mandate is that if tomorrow any internet protocol is going to be standardized by Internet Engineering Task Force, it has to comply with IPv6. IPv4 only protocol is not going to be standardized. All protocols has to comply to IPv6. Your protocol may be IP version agnostic, but if it but it should be written that way that IPv6 should it may either give you the same performance as IPv4 or it will give you better performance. But you have to comply with IPv6, and that's the mandate. So the conclusion is that IPv6 and 5G they will go hand in hand because one prime requirement is that the IoT kind of vertical that 5G is promising. So earlier 4G was not promising that I'm going to serve IoT, but 5G is promising that I'm going to serve IoT. Okay. So 5G, if it has to serve IoT, and if it has to serve this something called ultra dense network, so while they have to do a lot of work at the for interference management and all this, but they have at the same time they have to solve all these problems of accuracy and reducing the and making the thing scalable, right? So many operators, so one operator in the US, they have said that they are now moving all the way to IPv6. But practical thing is that IPv4 will still exist for quite some time. It will not just go away. So we are not yet in a time that we say that IPv4 has gone to Stone Age and we are going to IPv6. IPv4 and IPv6 are going to coexist. Why? Because many applications are still there which people are using. They rely on or they assume that they have IPv4 So there you may have a special rating so that IPv6 address is translated to the IPv4 address. Or you may have this special kind of the tunneling mechanism, and that is going to definitely reduce the performance of the network. And the study I mentioned, in some cases, they have seen that for these kind of intermediary arrangements, uh, the some in some cases performance has actually gone down and before. But we have to live with the practicality because it is a matter of investment, it is a matter of infrastructure evolving, it is a matter of. Okay. So with that, I would like to conclude. We have time. We have time. We can find. If you have any questions, I am here. Or I believe, okay, the first thing is that investment thing you said, I think that has been the biggest problem because many telecom operators they get to get back the investment they did for 4G. Yes. So because the cheaper best policy has not really worked. And the other thing is that I'm talking a little bit about the investment part because this is a very important point. You know, uh, for any technology that we are using, 3G, 4G, or 5G, whatever we will use, we are not producing any indigenous IPs. We are not producing any intellectual property. And so, and that becomes a hindrance to local manufacturers also because we are stepping out very late. And what is happening? I think there's a mobile phone manufacturing company. I read the story about them. I'm not naming that. That was an Indian company, but that had to succumb to the pressure of a Korean company, and they're no longer in the market because everything they do, they find that feature infringing with some other items. Right? That is a big problem. And honestly speaking, telecom is really screwed right now in India. I'll tell you one story. The others can I get in? I'll tell you one story. 2017, Prashant, I hope you are not. In 2017, I had to speak in Indian School of Internet Governance. And for that, the community was not technical community. So they are more from people from ministries and from NGOs and all. So I had to prepare on the economics law. Where is the problem? So what happened? We screwed it up at the time of 3G rollout. That is my understanding. Because we very hurriedly rolled out something called 3G, and that technology that we rolled out was good for nothing. That we wasted the time myself for the so the kind of data rates they promised, so people were not really understanding what to do with that data. And that is why you have seen that very successive HSDK, and all these things coming up. And then suddenly you had this 4G thing. Because the kind of services that people were expecting, the technology was not was too good for earlier voice and all these text and all these things, but it was too less for the video and all this kind of thing. But we hurried very much in rolling out 3G. So we had this Karunya and all this and that. When I had 500 rupees phone, which I don't know where as well. But if you look into the Chinese, China did not roll out 3G when we did. China rolled out 3G But by that time, Chinese government, because they have everything done through the government, all the corporates, it is the Chinese government who builds those corporates and tell them this is what to do. So China Mobile and all these service provider kind of they came into picture, and what they started to do, they started to develop on PDD that was particularly useful for China. PDD, CDM, PDD version, the time division location. And they created their in-house expertise. Right? And then they went to the standard body. I know this very well because at that point of time, when I was working in LTE, when you came for the customer in UK, so most of the boxes were getting sold in Beijing, and they were actually asking for PDD technology, which nobody was. PDD became proprietary to Chinese geography. Later it became popular. So the policy that we had taken at that point, I think we made some mistakes. That's why we became so much dependent on, because now we have missed out one bus, and bus after bus we are just trying to catch up and catch up. Right? So, but with 5G still has now you don't have a 5G rolled out here. In Spain, I have seen there are 17 cities. They already have 5G. Germany will soon have 5G. And they are now talking about China has already coined 6G term, and they have created a new corporation, CCIT or something, for this 5G and beyond. So this is something that students have to think about, that institutions have to think about. And so far as this rural connectivity is concerned, I think ISRO has a big role to play over there. I read somewhere that some of the news articles that ISRO will launch new satellites, and by 2020 provide broadband. That is something we should really look at, and we should target some more research